So let's go over the warm-up. Unmute yourself. First one, 2 times 2 is
4.
4.
Okay. Thank you. 2 raised to power 4 is
16.
10.
all right. Thank you. And then solve for x. So what's the value of x in number
2.
2? How did you get the 2?
64
2
to the
raised to
square
the
root of
6th power is 64.
Okay. Thank you. Thank you. So we got it. So now this what we just did right now is helping us to introduce the concept of exponents and radicals. And you have been hearing about exponents forever. You have been hearing it since you started learning PEMDAS. Remember PEMDAS, right? PEMDAS, as you know, the arithmetic operations. So P stands for what?
Exponents.
P.
Parentheses.
E.
Exponent.
Exponent. You see, so you've been hearing about exponents. So now we are going to deal more about exponents, and then it's going to lead us to exponential functions. So, and then radicals. Basically, exponent, sometimes it is called, some people call it the power. It's just the number of times something is multiplied. The number of times you multiply something to get another result. So that's what exponent is. So how many times, if for example, we're talking about 64 here. So if we just say 2 multiplied by 2, 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 1, 2, 3, 4, 5, 6. If it gives us 64, then we can write 2 as 2 raised to power 6 equal to 64. If it gives us 64. So now let's go. 2 times 2, 2 times 2, 4, 4 times 2, 8, 8 times 2, 16, 16 times 2, 32, 32 times 2, 64. So 6 raised to power 6 gives us 64. On the other hand, instead of writing, this one gave us, instead of writing exponent, the opposite of exponent. If I want to get back, this 2. So if I write something like this, let me write it. If I write 64, square root of 64 is what?
8.
8, okay. Square root of 64 is 8. Then how about this? How about cube root of 64? Cube root. What?
I think it's 16. Yeah.
Another try.
4.
Yes, it should be 4. This thing cube root just is simply how many times what is the number you can multiply 3 times in order to get 64? So it is something like, so the cube root should be, what is the number? You can write it this way. What I would say, that's what you ask yourself. So what is the number you have to multiply 3 times? 3 times. You know, you multiply by itself 3 times. Multiply by itself 3 times. 3 times. So now that's what you have to ask yourself. Now, if you look at the first one we did, if you look at this one, if we just come here and group this one, group it, group it, group it. So we are going to get 4, 4, and 4. So if we multiply 4 times 4 times another 4, that should give us 64. 4 times 4 is 16, then 16 times 4 is 64. So now that's, so the cube root of 64 is equal to what? Cube root of 64 is equal to 4. So that's how you think about it. Now, how about if I say sixth root of 64? What should it be?
2.
Yes,
2.
it comes down to 2. So that's the right way to think about it. So now we can see from what we just demonstrated now, we can see that radical is an inverse operation of exponent. Radical is an inverse operation of exponent. So just like division is an inverse operation of multiplication. Multiplication is an inverse operation of exponent. So if you have a number in exponent form, if you want to do the reverse of it, reverse operation, you are going to do the radical of it. So it can be second radical, which is a square root, or third radical, which is a cube root, or fourth radical, or fifth radical, or sixth radical, as the case might be. All right. So having said that, now let us examine how the different ways of writing this, different ways of writing the same number we just wrote, different ways of writing it. So instead of writing square root of 4, we can as well write square root of 2 raised to power 2. Is that correct? I need
Yeah.
a confirmation.
Yes.
Yes, all right. So now, instead of writing square root of 2 raised to power 4, we can also write 2 raised to power 2 bracket 1 over 2. So, which means you are writing the exponent, the radical is actually putting a number in fraction, putting the exponent in fraction. Once you have an exponent in fraction, that's a radical right there. So now if you see these two, this is like saying 2 times 1 over 2. So 2 crosses 2, which still gives us 2. And that's why square root of 2 is equal to 2. On the other hand, 64 square, the one we wrote here, this one, let's rewrite it. This one is root of 64. Sixth root of 64 can also be written as same sixth root. Then 64 is 2 raised to power 6. And 2 raised to power 6 can also be written as 2 raised to power 6 bracket 1 over 6. So this is 6 times 1 over 6. 6 crosses out to 6, and that gives us 2. So these are different ways you can write exponents, and different ways you can write radicals. Okay. So now the question becomes, why is this thing very important? These things are very important because there are so many mathematical and scientific problems that eventually results into a number being written in exponent form and the exponential function. As a matter of fact, currently, as we speak, you know, when they say global pandemic and they are talking about coronavirus, and they are essentially, the virus is spreading in exponential form. So there's what is called exponential growth and exponential decay. So we are going to come to that as time goes on, but we need to know how to represent numbers and scientific data in form of exponents and in form of radicals. Having said that, how about if you have a number like this? 27 raised to power 2 over 3. 27 raised to power 2 over 3. So how do you evaluate this type of a number? If somebody says evaluate 27 raised to power 2 over 3, how do you, what would you do?
Would you break up the fraction?
The fraction, you may. Is there another number? If you say, somebody say, let me put it in question form. Evaluate the number and I'm referring to this number. Evaluate it. So if I ask you to evaluate this number without asking you a particular, without telling you a particular method to use, what are you going to do? Just give me an idea. You don't have to get it right. Just give me an idea. I want to know.
You say it's 27 raised to 2/3.
Yes. If I say evaluate this number, you know, and I did not tell you use a particular method. So what are you going to do? Okay, if I say evaluate this number using a calculator, what are you going to do?
You would solve it in the calculator?
Yes, you put it in a calculator. So what are you going to put in the calculator? That's what I want to know.
You would put 27 raised to 2/3 in the calculator.
And then you press enter.
Yeah.
Okay, can you do that? Let's see what the answer gives you. Use your cell phone calculator and do that. If you don't have TI, you don't have is it TI 84? Use your cell phone calculator to do it, and let's see what you get.
I got 9.
You got 9? Okay, so I'm just going to write using calculator. So I'm just going to write 9. I'm not saying it is right, I'm not saying it is wrong, but we're going to verify it. Using calculator, solution equal to 9. That's what somebody said. Now, if I now say, without using calculator, evaluate that number, without using calculator. You know, in some of these tests, they ask you to not to use calculator, right?
Yes.
Yes, so now without using calculator, what are you going to do?
Wouldn't it be cube root of 27 squared?
Cube root. When you say cube root, are you going to write this cube root? When you say cube root of 27, are you going to write 27? Is that what you mean?
Yeah, and then the squared after the 27.
After the 27?
Yeah,
Is
27
it
squared.
like this?
Yes.
Okay, that looks correct. That looks correct. How about if you break down to 27? That looks correct. But let's try to continue to work and then see if there's another way of doing it. Now, how about this 27? Is there another way of writing 27?
You can keep 27. You can keep the square and do 3 times 9.
Okay, so somebody is saying we can do 3 times 9 gives us 27, right? Raised to power 2/3. Is that what you mean?
Kinda. I mean, I don't know if it's right, so.
It doesn't matter. We are trying to figure something out. You know, we are trying to figure something out. Yes, 3 times 9 is 27. How about if we write 3 times 3 times 3? Is that not the same 27? Is that not the same 27?
You could do 3 to the 3rd power.
It is. So can we now write 3 raised to power 3, which is 27, then raised to power 2/3. Is it not the same 27? Is it not the same number that we had originally?
Yes.
Okay, so that means all we need to do at this point will be the upper side of it, the exponential side of it can be written as 3 multiplied by 2/3. So 3 divided by 3 is 1.
1.
And then you are left with 3 raised to power 2. You are left with 3 raised to power 2. And 3 raised to power 2 is the same thing as 9. So the person who used calculator was right. On the other hand, if you just want to use calculator, for example, some of the functions in calculator, if you want to use calculator, here's what you can type. Here's what you can type. You can type, depending on the type of calculator you are using, but you can type 27 bracket, caret sign, open parenthesis, 2 divided by 3. And then you hit enter. And that should give us 9. That should give us 9.